Screen is visible?
Yes, sir.
Okay. So good afternoon to one and all. As per the schedule, actually, the morning, every day morning, we have arranged the communication improvement program. For that reason, tomorrow first practical hour is there. Instead of tomorrow class, today only I am going to conduct the practical today. Okay. So one experiment we are going to, I have already planned to finish today. So the practical is on, that is experiment number, how many experiments are over? 4, no? 4 experiments are already over. That is Whitson bridge, unbalanced, balanced, and measure. This is experiment number 5, that is measurement of low resistance by using Kelvin bridge. Actually, the bridges will comes under in the third unit, that is potentiometer and bridges. We have studied the experiment number 2, that is called the Whitson bridge. We have already discussed that one. Based on that, we are going to same formula we are going to use for the Kelvin double bridge, but it is applicable. The some disadvantages are there of the Whitson bridge. Those disadvantages are corrected by using this Kelvin double bridge here. The Kelvin double bridge, Kelvin has derived 2 bridges here now, one inside the another. Based on that, the name came for the measurement of low resistance. We are going to use the Kelvin double bridge here now. So the aim of this experiment is to measure low resistance by using Kelvin double bridge here now. So to perform this experiment, the main thing required is Kelvin double bridge kit is required. Just a minute. So the kit is required, that is called Kelvin double bridge trainer kit is required. And to compress the kit, we have to give the DC supply. For that reason, the DC supply kit is required. And to measure the voltage, digital volt multimeter is required. And to connect from one point to the another point, connecting patches are required here now. So these are the equipments required to perform the practical. Actually, for the theoretical means practically means that is in the physically you have to perform. While performing physically, these are the equipments are required. So both I am explaining here. So this is the circuit diagram of the Kelvin double bridge here now. This is the circuit diagram of Kelvin double bridge here now. So it has 4 resistors, mainly 4 resistors are there: R1, R2, R3, and R4. R1, R2, R3, R4. 4 resistances are there. So, and inside this one, this A, B, C, and 2A, this is act as one bridge, and A to D and C to A here now. So this act as another bridge here now. So for that reason, the R1 and R2, capital R1 and R2, we are going to consider as outer arm ratios here now, and the small R1 and R2, these are the inner arm ratios we are going to consider here now. And the connecting leads, whatever the connecting patches are there, that resistance we are going to use here now, that one also we are considering because we are going to measure low resistance here now. So the some connecting wires or cables, those are also having the resistance, though that resistance we are going to consider here as R here. The R we are considering here now, very small here now. So R3, by varying the R1, R2 is standard resistance, R3 is also variable resistance. These are the fixed value we are going to use. The Rx is the unknown resistance. Which one we are going to measure here? Which one we are going to measure this one here now? So the DC supply voltage we are going to give here now. Based on this circuit diagram, it has some derivation. Actually, we have to cover in the theory part. Within 1 hour, it is to complete all the basics. It will take some time here now. So what we will tell that one, here the circuit diagram is there. The circuit diagram is there here now. So the galvanometer is connected in between the point B and D here. The galvanometer is connected in between the point B and D here now. The voltage drop potential difference between AB and AD is equal, then the galvanometer is said to be as balanced. Or BC to DC it is equal, then the bridge is balanced. We can tell that one. So, or AC to AMD D here now. This one also AMD, that one also we can tell that one the bridge is balanced here now. So based on that, the potential difference between under balanced condition, there is no current flow here now inside this galvanometer. If the bridge is balanced, then it acts as an open circuit, no current will flow. Under that condition, under balanced condition, we have to identify the formula for the unknown value here now, unknown value of the resistance here now, whatever we are going to measure here now. So under balanced condition, no current will flow through the galvanometer, which means that the voltage drop between A and B here now, here and here, EAB between A and C here now, A to C are equal, we are going to call here now. So according to that, E to A, EAD we are going to calculate here now. Here A is there, here D is there. So based on that, the current, according to the current equation, voltage drop across this one here now, we can consider here the voltage drop across this one is which current we are passing here now, I current we are passing here now, IR3, like that. By considering this one here now, EAD is R1, this is A terminal is linked with R1 divided by R1 plus R2 we are going to consider here. We are going to consider R1 divided by R1 plus R2. And EAC we are going to consider this one here now. So R3 we have to consider first. R3 we have to consider plus RX. And this term, you just check out this term here now. It is in series or parallel. I'm going to draw this one only here now. See here. A to C, I will draw one more circuit here now from here to here now. See here. Here it will start from A. R3 resistance is there. Next, here some path current will flow. Here some current will flow. I will make two paths here now. This side, I will make R1 small R1. Next R2. Then this one is here. I will joint add it is. It is nothing but here some resistance is there. That is called R. This is R1. This is R2. And here Rx is there here now. That is called C here now. It is A. Now, can you tell me the resistance between A to C here now? This is Rx here. Rx. Based on this, we can find the resistance value. Equivalent resistance, we can write the equation. Voltage drop across this one only you consider here now. Okay. RAC, R equivalent, RAC equal to, is it audible or not?
Yes, sir.
Okay. First, the current will start here now. So we can write R3. We can write R3 here now. Plus here now. See here, these two are connected in series or parallel here now. R1 and R2. Series. So R1 plus R2 we can write. This total resistance is R1 plus R2. This branch resistance. Yes.
Yes, sir.
So this R1 plus R2 is in parallel with this R.
Yes, sir.
So this R1 plus R2 is in parallel with R. Yes.
Yes, sir.
So this R1 plus R, what I will consider? I will consider as capital R here now. Just imagine here now. So R and R here now. If two resistances are connected in parallel, then what is the formula? So just imagine if R1 and R2 are connected in parallel here now. R1 is in parallel with R2. How will write the formula? You don't know that one also. R1 R2 divided by R1 plus R2. Yes.
Yes, sir.
R1 plus R2 divided by R1 R2 divided by R1 plus R2. Here R1 means this complete term we have to consider here. No. So what I will do, R1 plus R2 into this is R divided by R1 plus R2 plus R here now, plus R. Is it correct? Next, this part is over now. This parallel part resistance we have found. Last, plus R3 here now. Plus RAX, it is nothing but RX. This is RAC here now. What is EAC? That is voltage equal to product of current and resistance here now. So EAMD, what we are considering here now. Sorry, EAC, what we are writing here now. I into I, if we have done this one multiplied into current, then that will become voltage here now. So same equation we have written here now. EAC equal to I, R3 we have written here, plus RX is there, plus RX we have written, and this complete term R1 R plus R2 into R divided by R1 plus R2 plus R. By considering this one here, we have written all the things here now. Next, EAMD here now, AMD, from here to here we have to find out here. So based on that, R3, this R3 plus R1 divided by R1 plus R2 here now, into this whole again the parallel equation we have to consider, that is R1 R2 plus R1 R2 plus R here. Same equation, parallel equation we have considered here. By considering these all the things, by making EMD equal to EAC here now. So EAC is this one here now. I will write here I into R3 plus RX plus R1 plus R2, same as it is, and equal to this one complete I will write here now, R3 plus R1. So I gets cancelled here and here I gets cancelled, and now arranging the equation that the R1 by R2 ratio, outer arm ratio equal to inner arm ratio, we are going to call that one. Capital R1 by R2 equal to small r1 by R2. We'll discuss deeply in the third unit. When the third unit will start, I will explain in more deeply. I will explain that one here now. So based on doing this equation, then the equation 3, this equation will become, what will happen here now? That is Rx equal to R2 R3 divided by, sorry, R2 R3 divided by R1 here now. The unknown resistance formula will get, that is Rx equal to R2 R3 divided by R1 here now. See here, what is the main resistance here? R1 R2 R3 R4. Previously in the Whitson bridge, same thing we have stated here now. So R2 into R3 equal to R1 R4. Like this we have done here now. Same equation we have identified here now. This one you have to remember, unknown resistance Rx equal to R2 R3 divided by R1 here now. So this is the simple theory part of the Kelvin double bridge here. So according to the physical experiment you want to do, that is, this is a procedure, but for the, we are going to do in the virtual lab, so this procedure is not applicable. And the observation table here now, you have to write R1 by R2 ratio and standard resistance R3 kitna hai, Rx whatever the measured value, and based by using that formula, what is the calculated value here now? Measured value, calculated value, measured value, calculated value, you have to do here now. So R1, R2, R3, we can consider that one. Based on that, you can do here now. So some precautions are there, and this formula you have to use here. And lastly, you have to write the conclusion. So I will start the virtual lab here now. The previously we have considered virtual lab also, no?
Yes, sir.
2 experiment we have already done by using virtual lab. Okay. So I will open. So what is that? Google Chrome. I will write here vlab dot this one vlab.co.in. I will write that one here now and just enter here. It is going to open the virtual labs, an initiative of the Ministry of Education, actually MOE, that is under the National Mission on Education through ICT content, we can call that one. And we have to go for electronic and communication here, basic branch for circuitry. The subject, it is there in here, analog signals, networks and measurement lab. You click on this. Click on this. Next, you click on list of experiments. List of experiment is you click on here. Last time we have done here 3-phase power measurement. Next, we are going to discuss here now completely related to the measurement subject. For that reason, where we have to click here now, measurement laboratory for UG students of EE, that is electrical engineering, EC, electrical and communication engineering, and instrumentation engineering here now. For all the circuitry branch, this is related here now. So where is the Kelvin double bridge? You have to search here now. See here, to study the Kelvin double bridge for low resistance measurement here. Is there? The title is there, Kelvin double bridge. I will click on that. I will click on that. It will open the Kelvin double bridge experiment. It is going to open here. So based on this, the same diagram we have discussed just now. Here R1, R2, sorry, R1, R2. This is R3 and this is the S is unknown resistance, like that only we have discussed. And the same thing we have discussed here now, EAD, EAB, EAC, EMD. Yes. By deriving the derivation also here also. So in the last R equal to P by Q, yes, into S we have considered. Instead of R1, R2, they have used PQRS we have used here now. So here they are considering as R is the unknown resistance here. No, this R is the unknown resistance. So R equal to P by PS divided by Q we can consider here now. P into S here now. This P into S divided by Q. Or suppose this is unknown resistance, then R into Q divided by P we can consider like that also. Which one we are going to consider as unknown resistance? Based on that, we can, the actual formula for this one is, you can write anything here now. That is called PS equal to QR. PS equal to QR. Based on this, we can write the R formula, that is called RSPS divided by Q. We can write the S formula, that is called QR divided by P. We can write the P formula, P equal to QR by S. We can write the formula for Q equal to PS by R. We can write anything, we can write here now. Any one resistance we can consider as unknown resistance here. So based on this formula, we have some different procedure is there for this. To do the virtual lab, the procedure is different here now. This is the circuit diagram you are going to get here now. That is called, again here they have used it in the different circuit they have used here now. First, as per this connect circuit diagram, what we have to do, we have to connect the circuit as shown in the figure here. You have to connect here. Next, set the value of resistance A at 100 ohm here now. This A is 1000 ohm we have to set here now by setting the plugs at marked position, and values of B at 1000 ohms here now. This B and this B you have to set 1000 ohms by setting a dial. Next, we have to open the key K here now. Where is the K switch here now? Here K switch is there, the DPDT is there here now. So we have to K, this one is the K we are going to use here now. Based on that, we have to keep this one as open switch. The bridge will act as Whitson bridge here now. This bridge acts as a Whitson bridge. So null deflection galvanometer will ensure the reflection, that is called outer ratio divided by inner ratio. You can call that one. A by B equal to this A by B. R1 by R2 equal to R1 by R2 use here na? Capital R1 by R2 equal to small R1 by R2. So next we have to close this switch here now. Make the close switch. Adjust the rheostat to obtain 2 ampere in the circuit here now. You have to adjust the rheostat to get the current here now. Next, keeping the resistance A at 1000 ohm, that A, this A, by keeping 1000 ohm only. Here, what we have to do, we have to vary the B, C, other resistances we have to vary. By doing that one, we can bring the bridge into balance condition. Then based on that, we can set the value of A at 1 ohm, 1000 ohm, 1 to 1000 ohm, anything we can get, and we can repeat the values by measuring that one here. So directly I will click on the simulator here now. We'll check the simulator with procedure here now. Here only will, according to the procedure, we'll start to perform the practical here. If the theory part is not clear, I am ready to explain once again here now how you got this one here now. P divided by EAC divided by, here in this place of EAC we are going to enter this value here. Then we will get, that is EAB. EAB equal to EAMD here now. EAMD is nothing but this is A, this is M into D here. So based on MD, it is related to here only, we are not going to consider. M is also, we can consider M is like that also, it is going to come. So this will become 1, 2 and 3 are in parallel again. Like that we are going to consider here. So this is the circuit diagram. See, the switch is provided here. The switch is provided here now. See here, to get the whatever the unknown resistance here now, we have connected for the patch connection here now. If either open hai to this part is opened here now. There is no short circuit here now. On that time, what will happen? The current will flow like this here now. So on that situation, what will happen? These two resistances are in series. These two will be in series here now. So the bridge will act as a Whitson bridge. If it is open circuit, I will draw the circuit also. You just check here somewhere. Suppose a part maine remove kar deta hu. This part is removed here now. This bridge will be look like this. Where I have to draw? I will take the spotlight, red color I will take better. It will be like this only, na? See here, these two are in series. I will make this one as one resistance here now. I will make this one as, and these two are in series. Again, I will make this one as one resistance. So galvanometer is connected here now. Whitson bridge aise hi tha na? Yes or no?
Yes, sir.
Yes, sir.
If the K is open, then we can say that that bridge is called Whitson bridge. It is acting as a Whitson bridge here now. If the bridge K is open here now. By making this open as close here now, by making this one into short circuit here now, by making this one as close, then we can identify, we have to bring the bridge into balance condition here now. So according to that, here the current flowing through this one, we are going to measure whatever the voltage is flowing here now, how much voltage is flowing. Based on that, we have to set the voltage value here now. See here, we can set the voltage here now. That is called, sorry, that is a current here. You can set the current, and if it is short, open, to make the bridge circuit also we can directly we can do here now. And this one, it has open and close here now, we have to keep here now. So we can, by varying this value up and down, we can set the value of resistance. This is also up and down, we can set the value of resistance. Here also we can change. This is standard resistance is there. This is the unknown resistance we have to measure here now. This RA, capital A, RB and RA, RB, this all resistances we can increase or decrease here now. These four resistances we can make increase, decrease to bring the bridge into balance condition here. Then this is a standard value, and this one is we can use for the unknown value we are going to get here now. So the standard value also we can change here now. You can, by setting this one, can change the standard value also. It is 0, 0.01, 0.02, can use that one here now. See, some current limiting resistance we have used, that is RS here. Source side we are going to use here. This is not countable here. Only for the limiting current we are going to use here now. The voltage we can increase, decrease here now. 12 volts, 10 volts, 15 volts also we can do here now. See here, according to the procedure, we'll follow that one. Can tell that one. Set the voltage V equal to 12 and switch on the board here now. Keep the switch yes in short mode and adjust the rheostat to maintain current 2 ampere. 3 ampere, 4 ampere or 5 ampere in the circuit here. We have to maintain this one 2 ampere, 3 ampere, 4 ampere. By adjust short circuit, we have to adjust this one here. We have to set the current here. So 12 volts I have considered here. No, we have set it. I'll switch on the supply. Okay, I'll switch on the supply. What is the current here? How much current is there here now? How much current is there? This side, this one, this is the ammeter here now. The current is 12 here now. What I have to do? I have to increase this one. By increasing this, we have to bring that current into 5 ampere or 2 ampere or 3 ampere here. 4 it came. So it is a current limiting resistance here now. I told previously. So I will consider for the 2 ampere. I will consider here now only. By increasing the current is inversely proportional to the resistance or directly proportional to the resistance. Is it audible? All of you? Audible है क्या? आवाज आ रहा है? Hello?
Yes, sir.
सो रहे क्या सब लोग? खाना हो गया बोल के? Okay, see here. How I am increasing the resistance, then the current will be decreased here. Now, previously resistance 1, the current was 12. Now resistance is 6, current will be 2 ampere here. Now, what is the voltage?
12.
12. Current is, sorry, resistance is 6. I equal to V by R. 12 by 6, how much it is? 12 by 6. 2 ampere we are getting here. Okay, it is in short mode here now. It is in short mode. This is a closed path now here now. It is not in the bridge mode. It is in the short mode is there here. Then switch yes to open mode and set low resistance value yes within the 0.0012 from set unknown resistance box here now. It is in the open mode here now. It is already in the open mode. By varying this one, we can change here now. See here, it is 0.06, it is 0.01, like that it is there here. I will set this one as 0.08. It is nothing but here now. It is yes is 0.008 is there here. We can note down that one. Yes, R3 equal to 0.004 here. You can note down this one. Next, then set the switch yes to bridge mode and switch K to open mode here. Now it is in the open mode only. I have to set this one into bridge mode here now. Some students are joining now. Already time is just a minute. This then set switch yes. This yes we have to keep in open mode first. We have to keep in open mode and set the low resistance value we have to set here now. 0.005 I will set here. Okay. Set the switch yes is this one here. Now we have to keep this one as open mode and set the low resistance value 0.005 we have to set here now. Then switch yes to bridge mode and switch K to in open mode here. This one I will set as bridge mode here now. So we have set it the bridge mode here now. The galvanometer is 0 or here very value is there here. This one, it is detecting some voltage here now. Yes, some value it is detecting. The bridge is the balanced condition or unbalanced now. I'm asking to you people only. If some value is there, then the bridge is unbalanced. What we have to do? By varying this one, we have to reduce the bridge value here now. Here it is not going. So this one, it is decreasing here now. It is again, it's okay. We can do here minus it went. No. No, minus. It will, I will increase here only. And this one also I will increase here. So 0.00, it is there here now. is going in up downside, na? 0.9. So 99, 1.09. So okay, 9. So it is coming down here now. See here, 5. Okay, it is 0, 0, 0 is there here.
Yes, sir.
So P equal to, this is, we can consider the P equal to this one 1.5, Q equal to 1.95, 095, and S equal to 0.0005, and X equal to R, PQ, R, this is R equal to, can consider, that is we have to identify here. What is the value of this one? We have to identify here now. So the formula, it will be like this. We have to identify unknown value of resistance. We have to calculate by using this one here. The S is already what we have considered here now, 0.05, P equal to 1.5, Q equal to 0.195, R equal to, we have to identify, R equal to, what we have to write, QS divided by P here now. Where is the calculator? I have yesterday found, I don't know where I have kept here now. 1.095 into 0.005 divided by 1.5. Something we are going to get. I will click on that one. Now it is not yet completed. We have to not yet calculate here now, because we have made this one as the Whitson bridge here now. We have made this one as balance, we have brought here now. Then vary the value of RA, RB, this one, this one, this one, this one, and from the control box below, directly put the values in the boxes respect to element to get zero deflection here now. A open circuit, this is open circuit, means it acts as a Whitson bridge now. It is acting as a Whitson bridge, it is acting here now. Now what we have to do, now set K with close mode here now. Whatever this one is there, I have to set in the close mode. Again, it will changes here now. See here, the value changed here now. Previously, we have set it that one as 0. Open means it is 0 was there, but now it is changed as close mode. It got some value here now. So again, by varying this one, we have to get the multimeter, this one voltmeter should 0 here now. For that reason, what we have to do, see here, 1.19, no, 0.2, 11, 55, 4, 3, 2, 1. Still it is there, 0.8. Here now it is 0, 0, 0. Got 0, 0 value.
Yes, sir.
What we have to do now, we have to calculate the value here now. By clicking on the calculate, we will achieve this value here now. It is going to display this X value or unknown resistance value here now. The unknown resistance is 0.00679 is there. 0.0067 is there. 1.095 into 0.005 divided by how much is there? That is 1.5. That is called, just a minute, 1.095. 1.5. 0.005. How much it is? 0.0006 here now. 0.06 into 10 to the power of minus 3 is there. 3 means that one only, the same. Okay. 0.00679 is our unknown resistance value here. This is the unknown resistance value here now. You can do that one. Next, similarly, what you have to do, you note down this value here now. This is the achieved value, calculated value of unknown resistance. You can call that one here now. Unknown resistance, it is practically we have obtained value here. Now you have to theoretically we have to do the calculation by noting down this value here now. R1, R2, R3, R4. By noting down this one, we can do here now. So next, what you will do, instead of this 0.005, again I will change that one. That value of the resistance I will change here now. I will close here now. Okay, I will randomly I will set some value into this RS and all the things. What I will do, I will make this one as open again. This one as close mode here now, or short mode here now. So from the short mode, what I will do, again we'll repeat that one. Different reading we will take that one. Instead of 12 volts, what I will do, I will give some other voltage here now. So it is not opening here now. We have to replace the page here now, because it is not taking other readings. It is not taking here now. Just a minute. Well, I have already made. Okay. Internet problem. Is it audible? Voice is clear?
Yes, sir.
Yes. It is not coming. How you are getting the voice? I have repressed this one. Then also it is not coming. So instead of this 12 volt, what I will do, I will use 15 ampere, 15 volts here now. Current, how much we have to use? How much current can I use? Now it is 15 ampere is there. I will set this one as 10 here now. So 1.5 ampere. Okay, I will instead of 3 ampere or 8. That is called 1.7. 2. That is called 7.5. Okay, 6 ampere current I will use here. Okay, the current is 6 ampere. Based Jaisa, how the high current will flow, based on that, this one we have to change here. So next, what we have to do, set current, we have set at that one. Next, yes value, we have to make this one as open switch here now, and this K also we have to make in the previously how it was short. Yes to be open here now. You have to keep this one as yes in the open mode. Then I will set this one as 0.01. I will set here now. See here how much it is there. 0.01 is there.
Yes, sir.
Okay. Set the switch K the value and here now. Next, what you have to do next? Then set yes switch yes in the bridge mode. I will set here now. Bridge mode means it is connected to the bridge here now. See here, when it was open mode, the 0 is there, galvanometer. Is that 0? When I will make this one as bridge mode, some value we are going to get here now. So this one, by varying these all 4 resistances, we have to make that one as bring into 0 value here now. We have to bring that one into 0, 1.1 09, okay, 088. One only. Leave it. It is 0.0001 is there. Here I will change that 101. Now it is 0 is there.
Yes, sir.
Okay, so 0 we have achieved here now. Now if this situation is open now, what I will do, I will make this one as close here now. Then again the value is changed here now. See, the bridge is unbalanced. When we are going to consider, this is only we are connecting one conductor here from here to here. The value is changed here, means the bridge will unbalanced. For that reason only they are telling small value of resistance will also vary here. Now for that reason, this small value of resistance also we are going to measure here. So the Kelvin bridge is suitable for small value of resistance measurement here. Now what we have to do, we have to bring the bridge into balanced condition here. Again, it is 1. So I have to decrease this one here now. 1.1, 0.9. Okay, here I will increase this one. 1.09. 0.5. 1.099 is not there, na? Still it is there, some value is there, minus 0.1. Okay. See here, it is almost 0 is there now. The value.
Yes, sir.
The bridge is bring back to the 0, or the galvanometer is detecting 0 means the bridge is under balanced condition. Now what we have to do? We have to calculate the value of this unknown resistance here. Now by clicking on this calculator button, it is going to calculate. That is called 0.01083 here. Now this is the unknown value of resistance we have derived here. Now like this, you have to practice this part. And whatever the values, you can take the screenshot and calculate that one. You have to enter in the observation table and complete the write-up part here. So already time is also going to up here now. So this experiment, when the previous Whitson power measurement and all the things what we have add to tables means the table was there, it was adding over there. But here it is not going to add over there here. Now you have to note down the value of, that is RA equal to 1. RB equal to, what is that, 0.9, and R3 equal to, that is 0.01 we have set it here now. R4 equal to, calculate, we have to do like this here now. So doing that one, this R1 by R2 ratio should be equal, and this R2 RA RB ratio should be equal here now. Then only we are going to calculate the value here now. So what we have to do, we have to, this is the calculated value here now, the shown here now. So it completes the experiment number 5, that is called Whitson bridge, sorry, Kelvin double bridge we are going to consider here now. So after that, some quizzes are there, you can attend that one, test the start the quiz and all the things, some questions will come here. Low resistances are provided with 4 terminals to eliminate the effect of thermoelectric, eliminate the effect of leads. This after studying this complete derivation theory parts, and the derivation is there in the 3rd unit. Once the 3rd unit is over, you can give this one, and by your name you can submit the test also here now. MCQ questions may come if for the practical oral examination. What references they have taken means the book references they have taken, A.K. Shawnee, that is called Electrical and Electronics Measurements and Instrumentation book they have considered here now. And Bruce Carlson also, it is there in the library. And A.K. Shawnee books are, so many copies are available in the library, and even in the teaching diary I have uploaded this soft copy of this textbook also. If you want to read more, you can refer this textbook also. You can refer this textbook also. So it completes the experiment number 5, that is called Kelvin double bridge method for the low resistance measurement here. And your class strength is 38, but you are only 25 members who are present. So remember one thing, I'm not, as a CC, I'm not asking you people. So as a TPO coordinator of the department, I am requesting you people that we are paying amount for the external resource person, whatever, which one today morning CIP session, whatever she has conducted, the Priyanka Datta madam. So you have to attend daily. It is we have planned daily for 10 to 11. The session is there daily 10 to 11. You have to attend that one, because the communication improvement program is necessary for you people for the next future of placement activities. So for that reason, we have arranged the session. So don't miss a single class. That is my request actually. You can consider this one as request, order, or whatever it may be. But don't miss a single class. Everyone should have to attend this session, and you have to fill that Google form, whatever I have said, Sawan sir has said with you peoples. Your attendance will count. Who will attend maximum, we are going to allow them for the next future placement activity. Who will not attend this session, we are not going to, who will maintain less than 80% attendance for this session, we are not going to allow for the next future placement activities. Remember that one. I am a TPO coordinator of department. I am giving you suggestion about that one. You have to attend and fill that Google form. Okay, will you attend, all of you?
Yes, sir.
Yes, sir.
You have to attend. Okay, we are paying some amount, college is paying, we are means you are not, no need to pay about any 1 rupee. The college is paying money for them, you take the benefit of it. All of you take the benefit of it, and you I'm going to upload that one in the CIP teaching diary. You can watch the videos also. If missed anything, you can watch that one. A division CIP ka teaching diary hai na, material where you will get that one, video lectures. You can watch over there. Okay, so
Yes, sir.
stop here only, and we'll continue in the next class. Just a minute. I have not taken the attendance. Don't leave the meeting. Roll number 1, 2. Sonal is there. 3, 2, 3, 4, 5, 6, 7, 8. Roll number 9, 11, 17, 15, 17, 19, 21, 23, 25, 27, 29, 31, 36, 37. Roll number 1, 2, 9, 11, 15, 17, 19, 21, 23, 25, 27, 29, 31, 36, 37. These are the absent numbers. Okay, I will end here only.
Sir, 36 is present.
Where you went? 36. Okay. Where is your name? I am not getting. Aptab Tamboli.
Yes, sir. Yes, sir.
36 roll number, you are telling that one. Your name is not in the alignment. Other people's they are using EE underscore SYB underscore your roll number. SYB 36, you don't use the same different number. How the rule is there? How other people's are they have named their profile name? Log out the Zoom meeting. You change,
Okay.
go to profile and change your name.
Okay, sir.
इधर डायरेक्टली चेंज मत करो, प्रोफाइल में जाके जूम मीटिंग का प्रोफाइल सेटिंग में जाओ, प्रोफाइल में जाके चेंज करो नाम.
हाँ हाँ ठीक है सर, करता है.
Will not count for the next session, huh? Remember.
हाँ.